For over 100 years, making light meant one thing: heat something until it glows. LEDs cheat completely. They make light cold straight from electricity. So how do they pull it off? First, what is light really? Light comes in tiny packets of energy called photons, like grains of glowing sand. A beam of light is just a stream of these little glowing packets. The old bulb makes light the hard way. Electricity fights through a thin wire, the wire heats white hot, and it glows. Here the light is only a side effect of all that heat, and that heat is a disaster. About 90% of an old bulb's energy leaks away as heat you never wanted. Barely a tenth ever becomes the light you were paying for. Now meet the LED, short for light-emitting diode. It plays a completely different trick. No fire, no glowing wire. It turns electricity directly into light, and that changes everything. Inside sits a semiconductor, a material stuck between a conductor and an insulator. Picture a drawbridge you can raise or lower. Sometimes it carries electricity, sometimes it doesn't. You control when. A diode adds one strict rule: electricity only flows one direction. Think of a turnstile. You can push through going forward, but try the other way, and it simply refuses to budge. The chip has two sides. One side has spare electrons, the other has holes, empty seats where an electron is missing. Where the two sides meet is called the junction. Here's the magic moment. An electron crosses the junction and drops into an empty seat, like a ball rolling off a step. As it falls, it dumps its spare energy, and out flies a single photon. That's the whole secret to staying cool. The energy goes straight into the photon instead of roasting a wire. LEDs still make a little heat, but almost none is wasted, unlike a glowing filament. So where does color come from? From the height of that step, called the band gap. A big drop releases a strong blue photon. A small drop, a gentle red one. Different materials, different steps. Red came in 1962, and green soon followed. But blue? Blue needed the tallest step of all, and it stayed impossible for nearly 30 years, stumping the best scientists on Earth. And blue really mattered. Without a blue LED, you couldn't make white light at all. So for decades, LEDs stayed trapped as tiny indicator dots on gadgets, never bright enough to light a room. Then, in the early 90s, 3 researchers tamed a stubborn material called gallium nitride and finally built a bright blue LED. In 2014, Akasaki, Amano, and Nakamura won the Nobel Prize. But how do you get white? Here's the clever part. Take a blue LED and give it a yellow coat. Some blue turns to yellow, and blue plus yellow reaching your eye together look white. And that's why LEDs won. Up to about 90% less energy, lasting up to 25 times longer, tough and instant on. The glow you're reading by is just electrons quietly falling into empty seats.